So the last part of section 6.5 focuses on solving a triangle, which basically means to figure out how long all the sides are and how big all the angles are. So in a triangle, there are 3 sides, 3 angles. Now, if I want you to solve a triangle, I have to start you off with some information. There's 2 different cases of information I could start you off with. In addition to the 90, you're always going to have a 90, so that doesn't really help. But in addition to the 90, I can either give you one of the other sides and one of the other angles. That would be case 1. Or I can say I'm not going to give you any angles besides the 90. You'll always have that. But I could give you 2 of the sides. Right? But either way, you're always going to have 3 pieces of information to start. A 90, and then one of these 2 cases. So, a couple of things you want to keep in mind when you're solving a right triangle. Pythagorean Theorem can be helpful, something we can use. I'll caution you about using it sometimes, and you'll see why. And the fact that all the angles in a triangle add up to 180. We can also use that to help us. So let's get to our first problem. So when we solve our first problem, we're going to use trig. Okay? We know 6 trig functions, but we're going to stick with sine, cosine, and tangent because those are the 3 you have buttons for on the calculator. Well, not that calculator, but maybe if I made it bigger. Yeah, sine, cosine, tangent. Oh, no, they were there. Sorry. Sine, cosine, tangent. All right. And how you figure out which trig function you're going to use is you look at the information that you're given in the problem, and you look at the information you're trying to find. Right? For example, let's say they gave you opposite, and you want to know adjacent. You'd ask yourself, okay, what trig function has opposite and adjacent? Sine, cosine, tangent. All right? So let's look at our first example. It says one angle in a right triangle is 37 degrees and the hypotenuse is 8. Now, they don't tell us what that angle is. We could call it alpha, we could call it beta. It doesn't matter. The goal in this problem when you're done is to solve for everything. So the first thing that I usually do is I set up a table. Just write down A, B, C. Those are my 3 sides. And then alpha, beta, gamma. Now we're going to draw a diagram, and then we'll start to fill information in on this table. So there's my triangle. Okay, the hypotenuse, it says, is 8. Okay, so we got that. It says one of the angles is 37. It doesn't matter where you put it. If you put it at the top or you put it at the bottom, you're still going to get the same answer for the other angle. Right? You're just going to be giving it a different name than whatever I get. That's all. So I'm going to put it at the bottom. Now, let's label the sides. This is A. This is B. You could have switched A and B. Right? A and B just have to be the short sides. C you don't want to switch. Always keep C as the hypotenuse. So, what that means is we know C is 8. What's the name of the angle that we always put across from A?
Yeah. Oh, no.
Yeah. Which one? It's going to be a Greek letter. So I'm looking for a Greek letter. Yep. Theta is a Greek letter. Not the one we use here, though. But it is a Greek letter we do use for a lot of other stuff. Yep.
Alpha?
alpha. A is always across from alpha. That means we just named the 37 alpha. Now, what Greek letter always goes across from B? Yep. Beta. Okay. So what I like to do now is put boxes around what I don't know. I don't know that. I need to find it. I'm sorry. This one, I wrote gamma because when we start doing triangles that don't have 90-degree angles, you're going to need a name for this third angle. Don't worry about gamma right now because you don't, it's just call it the right angle. So you'll see gamma when we don't have 90s anymore, but that's not this week. So we don't know beta. We do know the 90. That's fine. B, we don't know. A, we don't know. Okay. So those are the three things we have to find. Is there anything there that we can find relatively easy? You could probably find this as long as you know a little geometry and you don't even need trig at all.
Oh.
Yeah?
The other angle.
Yeah. How would you get the other angle?
Subtract 90 and 37 from 180.
Yes.
The sum of the right and the known angle.
Yep. So all the angles there have to add up to 180. So since you already used 90, you can just actually subtract 37 from 90.
Oh, yeah.
Sorry, it's the same idea. So that means that angle has to be 53 degrees. Now, when we continue in this problem, we're going to have to use one of these two angles to find A and to find B. You can use the same one twice. Which angle do you think would be a better choice to pick? Alpha or beta?
Alpha.
I agree. Alpha is better, but I want to know why you think that one's better. Has nothing to do with where they're positioned in the triangle at all. But why would alpha be a safer angle to use than beta? Yeah?
It's the original, so if you do it again wrong for beta, mess up.
Yep. All right. If beta is wrong and you use it to find A, guess what? Now you got A wrong. And if you use beta to find B, now you have B wrong as well. The way I'm going to show you how to do this, you're going to find everything using the original information, which means you could make a mistake on one part and it won't mess up anything else. Okay? So I'm going to circle the two pieces of information we were given. And now pick a side you want to do. There's no definite order you have to follow. You can do A or you can do B. Let's do A. Now we have to figure out the trig function to find A. It's either sine, cosine, or tangent. Look at A. Look at 37. What's the name of side A from the perspective of the 37? Yeah?
The opposite.
It's the opposite. What's the name of the side that's 8? Yeah? Hypotenuse. There's only one trig function that has opposite and hypotenuse in it. Is it sine, cosine, or tangent? Sine. Yep. So, I'll just write down what we're doing. I'm going to find A. So, the sine of, and then you always write your angle. Right? It's kind of like writing square root of, and then you fill in the thing you're putting in the square root. That's what we're doing right here. Sine of, now fill in the thing you're taking the sine of. Sine of 37 equals, excuse me, thank you, opposite over hypotenuse, 8 over A. A over 8. Opposite over hypotenuse. Now, last step is just to get that 8 on the other side so we have A by itself. How would you move the 8 over to the left?
Multiply by 8.
Yeah, just multiply by 8. And your answer is 8 sine 37. Okay. We do need to type that in and see what we get. Okay, what should I check on my calculator first? Make sure that this is all set, yeah?
Make sure you're in degrees.
Yeah, all the problems in this section are, I'm pretty sure they're all degrees. So put it in degrees, and then 8 sine 37. There's your answer for A. I'm going to go 3 decimal places. 815. So 4.815. Okay. So now we've got 5 out of 6 things. We have one more thing left to find. We're dealing with a right triangle, and you know 2 out of 3 of the sides. So what could you do to find the third side when you know 2 out of 3?
Pythagorean Theorem.
You could use the Pythagorean Theorem, but why do you think I'm going to say that's not a good idea?
If you messed up.
Messed up what?
The other side.
If you messed up anything, yeah. If you messed up this other side, right? If this other side is supposed to be 5.8, and you write 4.8, well, you just used something wrong to find something else, so now that's wrong. So now that we have A, forget about it. We're not going to use it again. We're going to use the 2 pieces of information that we're given. 37, 8, and now we want to find B. So now focus on what I circled in red. Okay, we already know 8 is the hypotenuse. Sam, what's the side that's B?
Adjacent.
That's the adjacent. Yep. And Emily, if we want to use a trig function that involves adjacent and hypotenuse, which one is it? Yep, good, cosine. So now we're going to find B, and we're going to use cosine. Cosine of, fill in your angle, equals adjacent over hypotenuse. B over 8. And same thing as the last one, multiply each side by 8 times 8, and there's your answer. 8 cosine 37. So we get 6.389. Now, we're going to write that down, and then there's a couple things we can kind of look at to make sure that that seems okay. That's not okay. First of all, the biggest side should always be in the row with the biggest angle. The smallest side should always be with the smallest angle. That happens here. Next thing you can check is any 2 sides added together have to be bigger than the third. Any 2. That's a rule in triangles. If you add 4 and 6, that's bigger than 8. If you add 8 and 6, that's bigger than 4. And if you add 8 and 4, that's bigger than 6. I think I checked them all. Right? But if you add up 2 sides and they're not bigger than the third, then something is really wrong. So everything there looks reasonable. Third thing you could do to check it is if you had time, you could do Pythagorean Theorem now. You could check, does 4.815 squared plus 6.389 squared equal 64, which is c squared, does it? It might come out to like 63.99 because you rounded, right? But a squared plus b squared should equal c squared, but only if you have enough time to check and do that on the test. That'll probably take another 20 or 30 seconds to check. Questions on that?
I think I'm typing it wrong on my giving me like the first one it gave me like negative answer and the second.
And you're in degrees.
Oh, I think.
Yeah, we'll have to check it after because this one, it's not really a lot of stuff to type in. It's just pretty much 2 things. Well, 3 things. The number in front, the trig function, and then the number inside.
Yeah.
We'll have to take a look and see.
Is she in radian?
That's what I asked. So if you put it in radians, you would get, for the first one, 8 sine 37. I mean, I did get a negative number there, so. Did you get negative 5 point something? Okay, then that's it. You're just in radians. Okay, so that's our first one. All right, let's look at this one. Bless you. Yeah, that one's from the book. It's number 39 on page 361, which I think is the same page as some of the questions from the homework for tonight. All right, start with the table. ABC, alpha, beta. No name needed for the angle across from C because it's always the right angle. Okay, so A is 12.3, alpha is 20, and let's put boxes around everything else. You can fill in the right angles, 90 if you want. I mean, I know it's 90, so that's not a big. All right, what's the easiest thing we can find there first?
The other angle.
The other angle. Yep. And someone else tell me what the other angle would be. Yeah. Yep. It's going to be 70. Now, do we want to use that angle that he just gave me for anything else in this problem? Don't use it. I mean, it's definitely right, but don't use it because if it was wrong, it messes up other stuff. Okay. What's the next thing we usually do to try to visualize this problem a little better? Draw it out. I mean, in my head, I can visualize, okay, this is opposite, this is adjacent. I can see it. But especially during a test, you might want something you can see, like physically on paper. All right. So A, B, C, alpha, beta. I'm just going to erase the ones that I know, or the ones that were given. So A is 12.3. Alpha was 20. Okay, I'll circle those because those are the two that I'm going to use each time. Now, I didn't write beta because I don't want to get messed up and accidentally use it. So I wrote it in the answer, but I'm not going to put it in my diagram. Let's do C first. Now we want to find C. Without me leading you through it, anyone think they can tell me which trig function we need to use? Find C. Yep. Opposite and hypotenuse. Sine of 20 equals 12.3 over C. Now, I'm going to show you a shortcut when you have a problem like this. We'll go through this kind of the first time, but then there's a trick. First thing I want to do is I want to get C out from being a fraction. So how would I undo dividing by C on both sides? Yep. Multiply by C on both sides. That gives you this. C times the sine of 20 equals 12.3. Now, how would I put sine of 20 over on the other side? Yep. Yep. Divide each side by sine of 20. So you'd have C equals 12.3 divided by sine of 20. I'm going to type that in a second, but look at what I started with. Look at what I ended with. Does anybody see what you can do without doing this step in the middle? Yeah. Yep. Anytime you have a fraction like this, that's a lousy beat. You can always swap what's by itself and what's in the bottom. So you could write this. Same thing. You can always swap what's by itself and in the bottom. And the reason why we went through on the first one. Okay, from now on, if I ever end up with an equation like this with a variable in the bottom, I'm just going to swap it with what's on the other side. Okay? All right, so what we got. Let's turn the calculator on. 12.3 divided by sine 20. Okay, so we get 35.963. Right, so it's kind of a big side, but I mean, it's across from the biggest angle, and we started out with a side of 12, so. All right, now let's find our last side. Find B. Bless you. Okay, so to find B, focus on what I've circled in green. What trig function am I going to use to find B? Tangent. So tangent is opposite over adjacent. Tangent of 20 equals opposite over adjacent. Now I got the same kind of setup that happened last time, so I'm just going to swap B and the tangent 20. All right. If you don't want to use that shortcut, you can go through it the long way, the way I showed you the first time. Shortcut is just to write this. And then type that in. Now, a couple things I can tell you about that number before we type it in. By looking at the information I already know. This is the middle angle. This should be the middle side. So it's somewhere between 12 and 35. The other thing I know is that if you add A and B together, it has to be bigger than 30, basically 36. Right? Which means B has to be at least 14. Right? If B is smaller than 14, wait a minute, I'm not sorry, 14, 24. If B is smaller than 24, that's going to be a problem. Because then A plus B won't be bigger than 36. All right? So it's got to be bigger than 24, but it can't be too big. It's not like a B could come out to 1,000. Because then if you added A and C together, it wouldn't be bigger than B. All right? So I can tell you that B is bigger than 24, and it's smaller than 48. It has to be. Otherwise, it wouldn't make a triangle. So let's see if it comes out to between 24 and 48. Without a calculator, that's all I could tell you. All right, so tangent 20. And we get a number between what I said we should. 33.794. And I put a degree on C. Yeah. Sorry, I should. Okay. Any questions on that? Okay, so that's an example of case 1, where they give you a side and an angle. Now, we're going to look at the case where they give us 2 sides. This is a little different. So they're giving you the hypotenuse and a leg. So let's make our table. And the right angle. And now we'll sketch it out. They don't tell you which side is A and which side is B, or which side is C. We have to figure out what the A, B, and C are here. But they do tell us one side is the hypotenuse, one side is the leg. How do you know which side has to be the hypotenuse out of the 2 that they gave me? About Eric?
The hypotenuse has to be the longer side.
Yeah, hypotenuse is going to be the bigger one. So that means the hypotenuse is 12.7. Call the 6.1 either A or B. It doesn't matter. Okay, the names that you pick for these sides and angles, the names are just a game we play in our head to keep track of things. The names aren't really that important. What's important is relationships. You put the right thing across from the right thing. Right? So if I put A here, then alpha has to go there. Okay? If I put B down here, then beta is up here. And C, we're calling the hypotenuse. You could just as well call the hypotenuse Q. doesn't really matter. But what's different now? What can't you do here right away that we could on the last two? That?
Like tangent.
Well, what did we do? What was the first thing we always found right away? We always found the angle right away because that was easy. You don't have enough information to work with to find the angle. But I am okay with you using something else this time that I didn't want you to use before. What am I okay with now?
The Pythagorean.
How come? Why am I okay with it now but I wasn't before?
They give you two sides.
Yeah. You're not plugging in anything into the theorem that you found. You're plugging in everything that was given to you. So Pythagorean theorem is fine to find b. Okay. So that's one thing that's different when you solve a problem with two sides. You will use the Pythagorean theorem. I'll show you the second thing that's different after we do this. So Chris, if I set up my Pythagorean theorem to find b, can you just tell me what that would look like?
Find b, the 6.1 squared plus b equals 12.7 squared.
Like that. Anyone have any thought about that? Yep. Yeah. That's going to be important because we're going to have to take a square root at the very end. Okay, so you know what? Let's do this all in one step. So we'd have to take the square root. And how would you move 6.1 squared over to the other side? Subtract it. So I'm not even figuring out what these things are yet. I'm just doing it like this. If you subtract the 6.1 squared to the other side and then take the square root, that's what b is. Another reason it's good to do it this way is because I haven't rounded anything off yet. If you square 12.7 and round it, and then square 6.1 and round it, and then subtract them and round it, and then take the square root and round it, you've rounded 4 times in the same problem. It's kind of a lot of rounding. So if you do it this way, you're going to round 1 time, okay, just at the very end. All right, so square root of 12.7 squared minus 6.1 squared. Right, we get about 11.139. That's b. Now, just like before, forget about b. You're not going to use it to find anything else. What you are going to use is this and this, somehow, to find the other 2 angles. Doesn't matter which angle you do first. So, Sam, you want to do alpha or beta?
Alpha.
Alpha. Okay. Same thought process. I need to look at that diagram and pick a trig function. Sine, cosine, or tangent. What trig function would involve everything that I have circled in red? Yes? Yeah, we're going to use sine. So now we're going to find alpha. So, sine of, now fill in your angle. We don't know the angle. It's alpha. Sine alpha equals opposite over hypotenuse. 6.1 over 12.7. What's different about that equation than the last 2 problems we did? Yep.
There isn't like a variable in fraction.
There isn't a variable in the fraction. There is a variable, but the variable is in the sine function. Okay? So we need to come back to that in a second because I need to show you what's going to be involved here. All right. So you guys picked the other angle, which is fine. So I'm just going to change it to this. So right now at this step, that's what you have. Sine is a function. Okay? It's like if you had this. Square root of x equals 10. Square root is a function. You can't get rid of square root with arithmetic. Arithmetic is adding, subtracting, multiplying, and dividing. You can only get rid of square root with a function that's the inverse of it, the opposite. So the opposite of square root is square. So same idea here. You can't get rid of a sine function by adding, subtracting, multiplying, and dividing. It's a word. It's not arithmetic. So what you have to do is use inverse trig. What inverse trig does is basically like doing something like this. The square root of 3 squared. The two operations cancel each other out. All right? So the notation we use for inverse trig is you write the trig function and you put a little -1 up higher. Now, something that's kind of confusing, that -1 is not an exponent. That -1 up higher is just a symbol that means inverse. Make it even more confusing? If you put a number there that's not a -1, it is an exponent. Okay? So putting a -1 there is just something extremely special that means inverse. That's all. Now, you'll notice next to it, I wrote 3 other things. That's an older way of writing inverse sine. Okay? Maybe before they could do exponents or something easy on like a computer. I don't know. But arc sine, arc cosine, and arc tangent mean the exact same thing as what's written on the left. We are going to use the notation on the left most of the time. But if on a test you see the directions and it says find the arc sine, and you come up to me and you say, I don't know what arc sine means, I'm not going to tell you. You have to know that it just means inverse sine. It's the same thing. Okay? So let's go back to our problem. And what we have to do at this step now is take the inverse sine of each side. Do not say multiply. Okay? This is an example where you multiply each side of an equation by something to solve it. Multiply by 2. If you had x squared equals 4, and I said to solve it, you wouldn't say multiply each side by the square root. You just say take the square root on both sides. Take. That's the word you want to use. Okay? So take inverse sine of what's on the left. I don't really have enough space, so I'm just trying to squeeze it in. Take the inverse sine of what's on the right. Inverse and regular sine cancel out, just like square and square root. And now we type it in. Second, inverse sine, 6.1 divided by 12.7. We get 28.706 degrees. Question on that?
I'm getting an error when I try that.
So you're in degrees, and you
Yes.
typed it in exactly like that. So you get the inverse sign, you get the parentheses, and the division sign in the middle. You get it that time?
Yeah.
Okay.
Oh.
So try to look back at what you did different, so you don't.
I had a bigger number in the front of on the left side of the division sign.
Okay. All right. Now, technically, if you were running out of time on the test, what I would do right now is I would just subtract that from 90 to get beta and hope I got alpha right. Okay. But if you have time, the better way to solve for beta is to use the 2 pieces that were given. So you're not using something you found to find beta. What trig function would I use to find beta? We already used sine, so this one is either cosine or tangent. Yep,
Cosine.
it's cosine. All right, so find beta. You're going to do cosine beta equals, what's going to go in the top? Yep, 6.1. And what about the bottom? Nice. 6.1 over 12.7. Now my goal is to get rid of that cosine. So what do I have to take on both sides?
Inverse.
Yep. Take the inverse cosine. Take the inverse cosine. So beta is the inverse cosine of 12.1 over 12.7. So if you're using one of my calculators, you can just pull up the last thing you typed in and just change that one thing. I don't know if that's easier, but yeah. So you get an angle of 61.294. Now, what do we know about all the angles? What's the rule about all the angles in a triangle?
Add up to 180.
Right, so you could check that now. Or just check alpha and beta and make sure they add up to 90. Or you might get like 89.999. Why might my answer be off a little bit?
Round it.
Because I round it. Okay. So that's what's different in the kind of problem where you're given two sides. You have to use Pythagorean Theorem, and you have to use inverse trig. That's the big difference. Alright, so that. That's another inverse trig with two sides one. Anyone need to see another one of those? If we have time, we could come back, but it's exactly the same. You use the Pythagorean Theorem to get one side first, and then use these two sides to get everything else. Alright, so let's find the 6 trig functions. Okay, so a little bit different now. We're kind of switching gears here. Of an angle that has a coordinate 2, 3 on the terminal side of theta. So you still need to know opposite, adjacent, and hypotenuse. That part we're going to use. Okay? But this is going to be a little bit quicker of a problem. All right. So let's try that out. It says that the point 2, 3 is on the terminal side of the angle. 2, 3. So that's the terminal side of my angle. Where's the initial side if they don't tell you? We talked about this when we talked about what's called standard position. The initial side is always where? Anyone else? Jared?
On the positive x side.
It's on the positive x-axis. Here's your initial side. This is theta, right there. So, what you could basically do is, to figure this out, make a triangle out of that picture. Just take a vertical line. That's a lot bigger than I needed. Just put it right there. And there's your triangle. And now, what I'm going to do is, I don't really have enough space to put theta in there and make it clear where it is. I'm just going to put a label. That's theta. So now we're going to find all the trig functions. We've got a triangle, but right now we only know 2 out of 3 of the sides. Brandon, how long is the bottom side? Kira? 2. 1, 2. What's the height, Chris? Great. Now, how do we get the third side? So it's going to be the square root of 9 plus 4, or the square root of 13. Now from here, this is just like a problem we did yesterday. Okay? Make this a little smaller. What's What's the sine going to be? Chris?
3 over 50 squared.
3 over
Square root.
3 over square root of 13, which then becomes 3 root 13 over 13 when we fix it. How about my cosine? Jared?
2 times the square root of 13 over 13.
Yep. And my tangent, opposite over adjacent, 3 over 2. My cotangent, 2 over 3. And the other ones, remember, we're just flipping them. So what would my cosecant be? Might be easier to think about what this was originally and then flip that. Yep. Yeah, that's the easier way to think about it. Square root of 13 over 3, square root of 13 over 2, and there's all 6 trig functions if they give you a coordinate on the terminal side of the angle. It's just basically, you're making a triangle out of it, that's all. Right? But you don't have to go any further than that. You're not finding out how big the angles are. That's what we did in, right before this. So now I'm going to take it that next step and I'm going to solve for the angle. Any one of these 6 pieces of information is enough for you to solve for the angle. You basically have 6 different ways you could do it. My advice, pick that one. Sine theta equals 3 root 13 over 13. How would you get theta by itself in that problem? Yeah. Yeah, exactly. You have to use the inverse sine. Take that on each side. And let's type that in and see what we get. So second inverse sine, 3 square roots of 13 divided by 13. Don't think I need any parentheses in there. It should work out okay. Yep, 56.31. Now, go back and look at my drawing. Yeah, looks reasonable. 56.31, it's a little more than halfway. And that's the size of the angle, 56.31. Roughly. So kind of like just what we did before. Now, that one was a little bit easier because it was in the first quadrant. Okay. What you always want to do is what we just did first. Use the inverse sine. That will tell you the angle. But what it's really going to tell you is what's called the reference angle. Let me draw what the reference angle looks like. Let's say you had, I'm just going to draw a triangle in every quadrant. So before, we only had a triangle in quadrant 1. I'm going to draw it, I'm going to mirror image that triangle in every quadrant. Right? And what does it look like? Yeah, that has nothing to do with anything. So we have a triangle mirrored in every quadrant. What I'm putting right here, I'm writing the word REF. That's the reference angle. Reference angle. Reference angle. Reference angle. The reference angle is always the angle that's tucked in between the hypotenuse and the x-axis. Okay, so the reference angle is always the angle between the hypotenuse and the x-axis. Now, this is what the actual question would ask. The question is not going to ask for the reference angle. The only time that the answer to the question is the reference angle is if you're in quadrant 1. Then there's nothing else you need to do. Because this is what they're looking for. Now, let's suppose they were looking for that. Look at that arc in red. If I told you what the reference angle was right here, how could you find out how many degrees that arc in red is? Yep.
Calculate the reference angle and then
Say the reference angle is 20.
you double it and then subtract it from 180. And then,
Where'd you get double it?
Oh wait.
Just minus from 180, yeah.
Yeah. I was thinking you wanted the angle between the two.
Oh, no, I got you. Yeah, no. So, if you're in the second quadrant and you find the reference angle by doing this, taking the absolute value of the inverse sine, you subtract it from 180. That's how you get that answer in the second quadrant. Now, let's say they ask you about a problem and the answer is in quadrant 3. How would you get that arc in red if you knew that reference angle?
180 plus the angle.
Yep. 180 plus the reference angle. So if that reference angle is 40 degrees, you've gone halfway plus 40 more. All right. Now, let's say they give you a problem and it ends up being an answer in quadrant 4. They're going to want to know this. How could you get an answer in quadrant 4 if you know the reference angle?
.360 minus.
Yep, perfect, nice job. 360 minus the reference angle. Because you've basically gone all the way around less the reference angle. Okay. So this chart is going to help us when we have a coordinate that's not in the first quadrant to find the angle. Okay. First, you find the reference angle using this right here. It's the absolute value of the inverse sine. Once you have that, follow this formula guide to figure out your answer. Okay. So this one says that 2, -3 is on the terminal side of theta. This doesn't even really require a sketch, but for those people that like things visual, we can do it. 2, -3. That's your terminal side. That's your initial side. What I'm asking you to find is that. The first thing you're going to find is that. That's going to be called, what's that called again? The angle between the x-axis and the diagonal? That's your reference angle. So we're going to find the reference angle first, and then we'll go from there. Yeah?
Wouldn't the reference angle be the same as in the example we did before?
Yes. So the reference angle would be the same. Okay, let's make our triangle, and I'll show you how that works. Here's your point. Make your triangle. This side is 2. This side is 3. That's exactly the same triangle I gave you guys right here. Bottom side was 2. The height was 3. It's just been flipped in a different quadrant. Right. So the hypotenuse, I think that came out, I need to erase this so I have some space. I think that came out to square root of 13. And I'm going to call that theta sub r. R stands for reference angle. Okay? So, the sine of my reference angle equals opposite over hypotenuse. 3 over square root of 13. It's exactly the same thing we did before. Now, if you look at that and you're like, wait, I didn't think we could leave square roots in the bottom. That's fine, because that's not a final answer. Now you're going to take the inverse sine of that. So, inverse sine of 3 over square root of 13. And that will give you your reference angle, which Jared already said is exactly the same reference angle we just had. What was the reference angle we had in the last problem?
56.31.
All right, so it's about 56.31. Now, look at what that equals. That's your reference angle. That's not your angle. Okay? This is your angle. So, what quadrant am I in this picture? Okay. I'm in quadrant 4. So I go back to my chart, or you could just look at the diagram if you're more visual. And the chart says to do 360 minus your reference angle. Okay. So take 360 minus 56.31, and that gives me an angle of 303.69. And that's the angle they were looking for. Okay? So if you're in quadrant 1, the reference angle is the answer. You have nothing else to do. If you're in quadrants 2, 3, or 4, follow the formulas that I just gave you. Okay. Any questions on that? All right. So I think it's the last two things. Yep. This is just a general pattern that you'll eventually notice, but if I ask you for the sine, the cosine, the tangent, the secant, the cosecant, or the cotangent of any of the quadrantal angles, the answer always comes out to 1, -1, 0, or undefined. The reason why is because, think about, in this diagram, where's 90 degrees? Yeah. Straight up. So could you give me a coordinate that would be on the terminal side of 90 degrees?
0, 4.
Sure. Basically 0, anything. 0, 4, 0, 5. Yep, anything. So he said 0, 4. 0, 4. Now, you might look at that at first and be like, wait a minute. I can't even make a triangle out of that. Right? You're right, you can't, because there's no real opposite adjacent hypotenuse. Okay? So when I have to do trig functions of a quadrantal angle, most of the time I have it memorized. But if I didn't, I would try to think of it the way we did it with unit circle trig. Sine was y, right? Cosine was that kind of stuff. Right? Or you can also check the answer on the calculator, right? But I'm just telling you, opposite, adjacent, and hypotenuse doesn't really work when you have a point on the axis, because you can't make a triangle. Okay. All right. And the last thing. We're going to use this diagram a lot in chapters 7 and 8, the one I'm about to give you. Because it's kind of important. But it's a diagram that tells you where the trig functions are positive. All right. So, in quadrant 1, all the trig functions are positive. That's what the A stands for. That means if you give me an angle between 0 and 90, that's in quadrant 1. If I take the sine of it, it'll come out positive. If I take the cosine of it, it'll come out positive. If I take the tangent of it, it will come out positive. Good try. Now, give me an angle in quadrant 2. That's an angle between 90 and 180. If I do trig on that angle, the only one that'll come out positive is the sine. Just pick a number. Give me any number between 90 and 180.
93.
93. Take the sine of 93. Positive. Take the cosine of 93, negative. Take the tangent of 93, negative. Okay? The only one out of the three that Jared just gave me, sine, was the only one that came out positive. Now, quadrant 3. Pick a number between 180 and 270. If you take the sine of it, it's going to come out negative. If you take the cosine of it, it's going to come out negative. Exactly what does it come out to? Well, that's not really what we're figuring out. Okay? We just know it would come out negative. Take the tangent of it, and it would come out positive. And likewise, if you are in quadrant 4, that's a number between 270 and it's really like 360, if you want to think of going all the way around. If you take the sine of a number between 270 and 360, it's going to come out negative. If you take the cosine, that's what the C stands for, positive. Okay? Cosine would come out positive. Tangent would come out negative. Okay? So ASTC. All the trig functions are positive, just sine, just tangent, just cosine. However you want to remember it. There's different ways people try. It's like all students take calculus or something like that. You know? So, or all calculus teachers smell, go with that. So any way you want to try to remember it, ASTC, okay? Tells you where certain trig functions are positive. That's all that chart tells you. Okay, and that's the second part of 6.5. Any questions on that chart? If you're wondering what's in parentheses, what did I put in parentheses next to the 180? What's the parentheses?
Radians.
It's radians. Yeah, it's radians. Okay. All right. So homework tonight. Same section as last night. Still 6.5. And the problems are 25 to 32, 40 to 42, and then 45, 49, 53, 57, 61. Don't forget, tomorrow I will be after school for extra help. Last test for the term we've got on Friday. I will give you the study guide. I have it for the midterm. If you know you're not going to be here, or for some reason you want it early, just come ask me and I'll get it to you right now.